So I ended up taking this chip off, and I wanted to just share with you the findings that yes, this short that we found is internal to the baseband CPU. And let me just show you how to determine that for yourself, because I don't want you guys to reball and put back on difficult chips when you know that the fault is internal to the chip and it's not under the chip. So this is the baseband CPU that I just took off of the iPhone 7 that was boot looping, that had a short on one of the baseband power lines coming out of the baseband power management chip. So let's look at ZXW really quickly and see that line. So let's find ZXW. Where is ZXW? Let's promote ZXW. Here we go. So here is ZXW, and what we found was that we had a short that we could measure in diode mode on these two caps. So we knew that this line, PP1V0 LDO9, was short to ground, and it could have been either due to a internal fracture or under a problem under the baseband power management chip. So we took off baseband power management chip. That was not the case. It could be due to one of these two larger caps becoming a wire. That was not the case. That really leaves in the likely category a short within, or in theory under, the baseband CPU itself, or one of the little caps. And the little caps generally don't fail. So what I did, I ran out of time, but then I just kind of wanted to know for sure. So I did take off the baseband CPU, which relieved the short. So that tells us that the actual cause of the short on PP1VO LDO9 was either internal to the structure of the CPU, the baseband CPU, or it was under the baseband CPU. Now, as far as mechanism, we have a stronger mechanism for the short being internal to the baseband CPU, because CPUs are made of ethereal neuron-like wires. And if you send the wrong voltage just for a second through some sort of an accident, then you can actually internally fritz up those wires, and that can be a mechanism for how you can end up having a short to ground within a CPU. And it's a fairly common way to damage a CPU. But let's prove that. So let's look here at the baseband CPU itself on ZXW, and we can see under or within this chip that these lines in red are the actual areas of the chip that sit on that shorted line, the PP1V0 LDO9 line. Now, if we look closely, we can kind of map the architecture of this chip. We have our A1 pad up here, and we can see in the sort of center square that we have a little bit of a cutoff area here on the corner, and directly opposite on row 2 are our two lines, or our two pads that are on that line. Now, where's ground? Because what I want to do is I want to test on the chip itself. What do we have for resistance to ground of the line in question and ground? So where's ground? If I click next to that, there is ground. So here we have ground in the second row at the very end, and we have our line next to that. So let's look at the microscope and see if we can confirm that short. So here's our chip that I took off, and for now I'm just going to go in straight up continuity mode, which asks, is there low resistance between these 2 points? And let's try it. So I'm gonna, this sits on the board like this, so I'm flipping it over, and I know that A1 is up here at the top. So I'm going to follow that row 2 all the way to the end, and I know that the very last guy on the end is ground, and the guy next to him is our line. So is that line internal to the chip, short to ground? And I get a beep in continuity mode. That doesn't necessarily mean anything because I don't know the actual normal resistance to ground internal to the chip. So let's measure in ohms. So with one probe on ground, let's measure in ohms, and I'm getting less than 1 ohm, 0.8 ohms. That's pretty low. That sounds like a short to ground. Now, just to confirm that maybe that's normally how 1VO lines are internal to the baseband chip, let's check another line. So let's go over and click on ZXW again, and let's just check the line down from that is another line that's called PP1V0 SMPS5. So this is another 1 volt power rail that is internal to the baseband CPU. So let's just check the resistance of that line to ground. So we'll stick on ground, and then instead of measuring our line, we're going to go one line down to a really similar line and see what the resistance is on that. So let's do that really quickly. So let's get our microscope camera back up and let's do it. So let's go to ground, which is here at the end in continuity mode first. So ground to our shorted line is a beep, and the next guy down, no beep. Let's go ahead and measure resistance, straight up resistance to ground in ohms. Ground to our line is about 1 ohm or less, and on the line down, it is 437 ohms to ground. We can do the same thing in diode mode. Red probe on our ground, red probe on ground. And measuring in diode mode on our line, it's 0.001. And the next line down is 0.280. So 0.280 sounds like a really healthy, normal diode mode reading for a healthy line. 0 does not. So this proves for sure that the original cause of our iPhone 7 boot looping was because it just all on its own, no water damage, no physical damage, no obvious bend, it developed an internal short to the unique baseband CPU that's required for that device. Now, whether or not there's some kind of magical baseband CPU programmer, I don't know. Maybe that'll come along and be commonplace, but at least for data recovery, I don't think you're going to be able to read what you need to off of this chip. Maybe you don't have to, maybe you can just kind of go look up that information and reprogram it. I don't know whether or not you can recover data from some sort of reprogrammed baseband CPU. Don't know about that. That's all sort of for the future, and hopefully you guys will figure that out. If you have a baseband CPU reprogrammer or know about it, then post over on iPad Rehab Forum and let us know what the current status is, because as far as we're concerned, this is a not recoverable phone, and it's not repairable even to be a phone again when it has an internal short on a chip that's unique to the phone. All right. So there we go. I just wanted you guys, since I was still here and I kind of found that out, I thought it would be good to sort of just tag this on to kind of complete the first stream we did. So the first stream is kind of detailing how we walked through the boot looping issue until we found the actual cause, and then now I left that stream to go pick up the girls, and I wanted to just kind of get that final answer to see that the short is indeed gone. So the short is no longer on the board, and we know exactly where it is, internal to this chip.